Hey guys, this is an 8th grade task. This is parallel lines cut by a transversal. I've actually recorded this before last night. The video is 16 minutes. It was way too long. So I figured I'll do it again, do it over, except I won't define each one of these different types of angles. We'll just do different examples. We'll talk about it. We'll go through it and move on. Alright, so parallel lines. So A and B are parallel lines. They are cut by another line, and that line is called a transversal. Okay, so you see the parallel lines here. A and B are parallel. They won't touch each other. If they were to continue on this plane forever and ever and ever, they won't touch each other, kind of like railroad tracks, basically. And this line, this rogue line that's coming through, is a transversal. So you're going to notice a couple things. This up here, 1, 2, 3, and 4. Looks very similar to 5, 6, 7, and 8. And they should, because whatever angle this creates, as this line's going through A here, it's coming at the same approach here. So it's going to create very similar angles. And you're going to see that here in a second. So corresponding angles. What are corresponding angles? Well, angle, let's see, give a different color here. Angle, let's do 2 and 6. So 2 and 6 are examples of corresponding angles. So angles 2 and 6 would be one example. Also, 4 and 8 are corresponding angles. So angles 4 and angle 8. Let's see, I'll put these in parentheses. I don't know if that's going to make things better or worse. I don't know. But anyways, so those are examples. So whatever this angle is, let's say it's 130 degrees. If it's 130 degrees here, it's also 130 degrees here. Okay? Likewise, down here, if 1 and 5 are going to be equal to each other as well, right? I just won't put the angle measurement down there. 1 and 5 are equal to each other. Also 3 and 7. 3 and 7 are equal to each other. Those are corresponding angles. So you've got quite a few. Okay, quite a few. You've got 4 pairs. For alternate interior angles, okay, the key word there is interior, and obviously alternate means on the other side. So if you look here, interior is what occurs inside the parallel lines. So you've got 3, 4, 5, 6. 3, 4, 5, 6 are those are the angles that occur on the inside of the parallel lines. Those are your interior angles. Your exterior angles are angles that occur outside of those parallel lines. So 1, 2, 7, 8 are exterior. Okay. Now let's talk about alternate. Alternate means every other. So for example, let's do the alternate interior. So alternate interior 3 and 6. 3 and 6 would be alternate interior. 4 and 5 would also be alternate interior. So again, if let's say 6 is 130, if this is 130, that means 3 is 130 as well. If 4 is 50 degrees, that means 5 has to be 50 degrees as well. Okay, so those are your alternate interior angles. Alternate exterior would be on the outside. So 2 and 7 would be alternate exterior. And then 1 and 8 would be also your alternate exterior. Alright, so far we've talked about angles that are equal to each other, that have the same measurement. Okay, now let's talk about same side interior angles. Same side would be on the same side but on the inside. So 3 and 5, now they're not equal to each other at all. Okay, 3 is obtuse, it's larger than 90 degrees. 5 is less than 90, you can see it's acute, it's an acute angle. But combined, okay, these are what we consider supplementary angles, right? So angles added together that create 180 degrees. So 3 and 5 would be same side interior. 4 and 6 would also be same side interior. Okay? So those two pairs would create 180 degrees. Now again, this seems complicated. There's a lot going on here. I do admit that. But I think sometimes math tends to make something that's simple overcomplicated. So let me go back real quick with a kind of a general or an overview, or maybe like a 30,000 foot view, if you will. If, let's say, angle 1 is 50 degrees. So if this is 50 degrees, that means angle 2 has to be 130 degrees. There's no ifs, ands, buts about it. It's got to be 130 because both of those angles combined equals 180 degrees, a straight line. Okay. Now the cool thing about this is everything else in this is going to either be 50 or 130. That's it. You only have two choices. So one easy way to do it is I look at every obtuse angle, right? 2, 3, 6, 7, and I'm going to label them all 130 degrees. Because guess what? That's what they have to be. They can't be anything else because these are parallel lines, right? They're going to have the same angle measurements because you have one straight line cutting through both pairs of lines, or one pair of parallel lines, I should say. So that means every acute angle is 50 degrees. So this has got to be 50, this has got to be 50, this has got to be 50. And what you're going to notice is what you have happening up here is occurring likewise down here. Okay, if you can get that concept down, this is kind of secondary. Even though I know in math that's important, definitions are important, and you need to know what you're talking about. But at the same time, if you get the concept down first, that's the key. Get this second, but this is important. Okay, I'm not trying to shy you guys away from that at all. So get to know these terminology, but this is really getting to understand this concept is probably the most important when it comes to transversals. All right, so let's do an example. So example 1. So what you're going to notice here is instead of numbers, we have letters. And so what they do is they typically will do that. Multiple reasons, but I'm not going to get into it now. But if you look, we're trying to figure out what is the measurement of YVW. So YVW is going to be right here. So this is YVW. Okay. Basically, they're looking for what is the angle, what's this angle right here? What is 6x equal to? Okay. Well, we don't know. Okay. We don't even know what x is, let alone what 6x is. So this other angle here, 3x, is going to play a part in helping us determine what that's going to be. Now, if you look earlier here, remember we talked about same side interior angles? Right? Remember we talked about 3 and 5? 3 and 5 combined would equal 180 degrees, correct? 4 and 6 combined would equal 180 degrees. So same concept here. These are same side interior angles. So if we were to add 3x plus 6x, we should get 180 degrees. Now the question is, well, how do we solve for each one of those? Well, it's simple. Combine like terms, set it equal to 180, solve for x. X is going to equal 20 degrees. And then all you need to do is plug it back in. So plug it back in where x is. Figure out which each of those individual angles are going to be. So if x is 20, 3x would be 3 times 20, which would be 60 degrees. So this has to be 60 degrees. Okay, let me use a different color. So this has got to be 60 degrees right here. Okay. And 6x, so again, x is 20, 6 times x, 6 times 20 is 120 degrees. So that means this has to be 120 degrees. Okay? So again, same thing applies up here. Everything else in here, in this transversal, and on this transversal, all these angles are going to either be 60 or 120. So if this is 120, this is 120. Okay? These are what we call vertical angles. If that's 120, this is 120 because these are corresponding angles. Vertical angles again. Right? Then everything else has to be 60 degrees. So that means this is 60 degrees, this is 60 degrees. That's 60 degrees, this is 60 degrees. And so once you've got that figured out, now you got to plug in which one's which, right? So YVW is what? 120 degrees, right? It's obtuse. So write down 120 degrees. VWZ, okay, that's your 3x. That's basically going to equal 60 degrees. So you write 60 degrees. And that's it. Okay? So let's do one more example. Same thing. We're going to refer to them by their letter. And so GDE is 4x. Right? BEF is 6x. So we got to figure out what these two angles are. Now they're different. We can see one's worth 4x, one's worth 6x. This is worth a little bit more. So I can already tell you right now, those are going to be different angles, right? Different angles. So they're probably going to be supplementary. If you add those together, it's going to equal 180. Okay? But let's make sure though. So if this is 6x, that means this angle up top here has got to be 6x too. These are vertical angles. Another way to think about it is this. 6x, let's see if I can move this somewhere. Okay, so 6x is going to be equal to this angle right here, ADE. ADE is also going to be 6x as well. Okay, so let me write that up there. It's not going to really change anything. I'm just going to clarify. So that's also going to be 6x because these are what we call corresponding angles. They have the same angle measurement. Okay. Now, if we add those together, these are what we call supplementary angles. 6x plus 4x has to equal 180 degrees because that's a straight line. Okay, or a straight angle. If we add those together, combine like terms, solve for x, divide both sides by 10, x equals 18 degrees. And then all you gotta do is plug it in. So if that's 18, that means 6 times 18 is going to give you this measurement over here. And 4x means 4 times x, 4 times 18 is going to give you this measurement over here. So when you figure that out, you get 72 degrees here. And then you should get 108 here. And that's all you need. That's going to tell you what everything else is. So again, every other angle, all 8 angles are either going to be 72 or 108. So if this is 72, this has got to be 72. If that's 72, this is also 72 degrees. This is 72 degrees. And then everything else has to be 108 degrees. So if this is 108 right here, this is 108 because these are vertical angles. If that's 108, this is 108. These are corresponding angles. Vertical angles again. Okay? So again, you've got, on a transversal, you've got 2 angles that are going to permeate through the rest of this. So it's either one or the other. Okay? So let's take a look at, let's solve this. GDE. GDE is 72 degrees. So we're going to write 72 degrees. Let me write it in red. BEF. BEF is 108 degrees. And then CDG. CDG, 108 degrees again. Okay? And then you're done. And that's all this lesson's about. So again, transversal, parallel lines intersected by a line, a rogue line, which is called the transversal. That's what's labeled T there. And it creates very similar angles. So once you've got one pair of supplementary angles, you just write them down again. Okay? You see how they're right here, then they flip here. So hopefully you noticed the pattern. And if you have any questions, let me know, and I'll catch you on Zoom. God bless, and good luck. Take care. Bye-bye.